Problem number 18. The average arithmetic mean of x and y is k. So the average, so x plus y over 2 is k, right? That's the average of x and y is equal to k. Which of the following is the average of x, y, and z? So they want to know what x plus y. So the average of x, y, and z is you add up all the numbers and you divide by 3. So they want to know it in terms of k and z. So let's just if we could substitute for x plus y, then we'd be done. So multiplying this equation by 2, we get x plus y is equal to 2k, right? Just multiplied both sides by 2. And then x plus y is 2k, so let's just substitute 2k here for x plus y. So then you just get 2k plus z over 3. That's the average of x plus y, x, y, and z. 2k plus z. And that is choice 2k plus z over 3. And that is choice A. Choice A. Problem 19. Problem 19. We have a neat drawing here. Let me see if I can draw this. Let's see, we have a circle. And then we have a triangle inside of that. So, well, it's not really inside of it. It's kind of does something like, see, the triangle goes like that. And then we have another line that kind of goes, oh, well, close enough. I don't, close enough. I think you get the point. It actually kind of touches at the bottom there. This is actually touching at the bottom. And then we have, we have another line that goes down like this. All right. Okay. This is O, Y, X, W, Z. This is W. Let me do a better color. W. Okay. It's O and V. All right. In the figure above, triangle XYZ is equilateral. Good to know. Width side of length 2. So this side is 2, this side is 2, and this whole side is 2. If WY is the diameter of the circle with center O, so WY, this is the diameter of a circle with center O, then the area of the circle is fascinating. So essentially, we just need to figure out what the height of this line is. Because if we know the length of this, we can figure out the area, because that's the diameter. We know their area, radius, and we use pi r squared. So how do we figure that out? Well, this is an equilateral triangle. And so that means all of the sides are 60 degrees. All of the angles are 60 degrees. So that's 60. This is 60 degrees. And now this whole angle up here is going to be 60, but we split it exactly in two, right? So this angle is going to be 30 degrees. And this angle is 30 degrees. And if you don't believe me, how else do we know that? Well, they tell us that this is a right angle, right? This is a right angle. This is a 90-degree angle. So that's how we know this was actually split in two, because if this is 90, this is 60. They have to add up to 180, so this angle up here is 30. So I think you are going to see now that this is a classic 30, 60, 90 triangle, right? If this side up here is 2, then we know that the side opposite the 30-degree side is half the hypotenuse. This side is the hypotenuse right here. The 30-degree side, the corresponding side to the 30-degree side, or the opposite to the 30-degree side, is half the hypotenuse. If this is 2, this is 1. And that also makes sense because this is a symmetric triangle, and I mean this kind of W is the midpoint because it's perpendicular and these angles are the same. So this would also be 1. So 1 and 1 and 2. 1 plus 1 is 2. So that makes sense as well. And then we know, and if you forget this, they actually give you the formula at the beginning of every SAT exam, that the side opposite the 60-degree side, which is the side we're trying to figure out, that's square root of 3 times this side. So square root of 3 times this is what? Well, it's square root of 3 times 1, which is square root of 3. And if you don't believe this, you could kind of try the Pythagorean Theorem, right? Square root of 3 squared plus 1 squared is equal to, well, 3 plus 1, which is equal to 4, which is equal to 2 squared, which is equal to 2 squared, which is equal to hypotenuse squared. So we figured out this diameter right here is square root of 3. The whole thing is square root of 3. And now if the whole thing is square root of 3, what is the radius? The radius is going to be half of that. The The radius is half of that. So the radius is square root of 3 over 2. And now we're ready to figure out the area. Area is equal to pi r squared. And they give you this formula too at the beginning of the SAT. So area is equal to pi times square root of 3 over 2 squared. And that equals pi times square root of 3 squared is 3 over, and then 2 squared is 4. So 3/4 pi. And that is choice 3/4 pi is choice C. Choice C. Image, clear image, invert colors. All right. Problem 20. And we're already at the end of this section. Problem 20. When 15 is divided by the positive integer k, the remainder is 3. So 15 divided by k has remainder 3. I'm lazy. How many different values of k, for how many different values of k is this true? So when 15 is divided by k, you have a remainder of 3. Interesting. Okay. So essentially, the actual easiest thing to do is say, well, 15 divided by k, well, is going to be essentially, the easiest way, I'm just trying to think of whether we should just do it by brute force. We can actually just do it by brute force because it says k is a positive integer, right? So what values of k work? Well, does k equal 1 work? When 15 is divided by 1, there's no remainder. So k1 does not work. K equals 2. So let's just do it. K remainder. 1, 2, 3, 4, 5, 6, 7. Right? It's going to go all the way up to 15. 8, we could keep trying. So when you have a remainder, when 1, the remainder is 0. 2 goes into 15 7 times with the remainder 1. 3 goes into 15 with the remainder 0. 4 goes into 15 with a remainder of 3. Right? Because 4 gets to 12, and then you have a remainder of 3. 5 has a remainder of 0. 6, once again, 6 gets to 12, and then has a remainder of 3. So 6 works. So 4 and 6 work. 7 has a remainder of 1. Right? 7, 14, remainder of 1. And then if you just did 8, 9, 10, 11, 12, 13. 8 has a remainder. Well, 8 has a remainder of 7. 9 has a remainder of 6. 10 has a remainder of 5. 11 has a remainder of 4. Right? 15 divided by 11 is 1, remainder 4. 12 has a remainder of 3. So 12 works. 13 has a remainder of 2. 14 has a remainder of 1. And then 15 has no remainder again. So the numbers that work for k are 12, 6, and 4. So it's essentially the factors of, well, I can't actually say that. Well, we just did it by brute force, and that those are the 3 k's that work for this problem. So the answer is choice C. I'm trying to think if there's a faster, elegant way of doing this, but this actually didn't take too much time. But anyway, that's all for this section. I'll see you in the next SAT section.